the radius of the circle whose equation is given by x squared plus y squared plus 6x minus 4y minus 12 is equal to 0. Now this doesn't look like any equation for a circle that you're used to seeing, but the idea behind this is actually going to be complete the square. So the first thing I want to do to complete the square is that we have to move this constant over, right? Because we only complete the square with the first two terms of a perfect square trinomial. So I want to add a 12 to each side. So our equation looks now like x squared plus y squared plus 6x minus 4y is equal to 12. And now I want to complete the square with the x and the y, so I'm just going to use the commutative property of addition and move things around a little bit so that it looks more organized. So I want to put x squared plus 6x together plus y squared minus 4y together is equal to 12. And the reason I left these big spaces is basically because we know since we're completing the square, we're going to be adding something to those big spaces. So again, I've just moved them around. I haven't changed anything at all. So now we get to complete the square with both terms. So for the x, to complete the square here, what we do is we take the coefficient of x, divide by 2, and then square the result. So 6 over 2, that's going to give us 3 squared, which is 9. So we all want to add a 9 to the left side of the equation. But remember, equations are like a seesaw, right? You want to balance out both sides. So if we add a 9 to one side, we have to add a 9 to the other side. Now, for the second equation, we want to do the same thing. So we want to take the coefficient of y, which is minus 4, divide by 2, and then square, because that's how we complete the square. So we end up getting negative 2 squared, which is 4. So I want to add a 4 to this side, and I want to do the same thing on the right side. So now what does our equation look like? This is x squared plus 6x plus 9. I'm going to keep my parentheses, even though I'm just adding these two together. And then y squared minus 4y plus 4 is equal to 12 plus 9 plus 4, that's 12 plus 13, which is 25. So now, notice that in x and y, these two are perfect square trinomials, right? Which means that when you factor them, this is going to give us x plus 3 times x plus 3, which is also known as x plus 3 squared. And similarly, in the y, you're going to get what? X minus 2 squared? Right? Because if you FOIL it back out, oops, sorry, y minus 2 squared, excuse me, you're going to get y minus 2 squared, and if you're never sure, you can always check. When you FOIL these back out, you get y squared minus 2y minus 2y plus 4. So that checks out. So now, let's replace it with the factored forms. So x squared plus 6x plus 9 is x plus 3 squared. And then y squared minus 4y plus 4 is y minus 2 squared is equal to 25. And now this is looking a little bit like the formula, the equation for a circle, right? We're just missing a little bit of cleaning up because we want it to look like x minus a squared plus y minus b squared is equal to r squared, because that way it's the easiest way to find the center and the radius. So let's do that. So x plus 3 can be written as x minus negative 3 squared. The y minus 2 can stay the same since it looks like y minus b. And then 25 is written as 5 squared. So now the center, let's pick a nice dark green for this. So the center is at a comma b, right? So in this case, it's negative 3 comma positive 2. And the radius is 5. So that is the center and the radius for our circle.